Hello. Imagine that you're an application security engineer that was recently hired by a small young company or even startup without any mature application security process. Or you are not a security guy at all, but your CTO asks you to be accountable for an application security. The application that your company developed is a microservice-based application, and you are the only one person responsible for an application security. You probably used OWASP SAM or similar framework in order to establish your application security process. You provided self-assessment, created a roadmap, and even started to implement some application security practices like security testing or static code analysis. But at the end of the day, one day you understand that you have to implement some activities from design portion like threat assessment or security architecture. But in order to do that, you need some input information about application architecture like high-level design or something similar. But if your company is a young firm without any mature development process, there are probably no such artifacts at all, or several artifacts are in place, but they maybe not be up to date or suitable for an application security activities. So you as an application security engineer, you have to choose and establish some simple approach on how to collect security specific information on application architecture. And the goal of my presentation is to offer some proposal on how to collect microservice-based architecture information to secure your application. My name is Alexander. I'm from Russia. Currently, I'm working for Advanced Software Technology Lab from Huawei. I have an experience in securing microservice-based system and application security evaluation. In my spare time, when I'm not spend it with my family, I deliver a lecture on application security at Bauman Moscow State Technical University, and also try to contribute to OWASP community. So why do we need to document security architecture? It may help us to answer a huge amount of security-related questions, mostly from authorization and authentication scopes. So for example, what permissions does microservice minimally need to access other microservices APIs? Or what grants does microservices minimally needs to access databases on messages queue? What storage or message queue do contain sensitive data? But dealing with a young company, all we usually have is just the repositories with the source code, maybe some articles on Confluence or PowerPoint presentation with a high-level design. On the other hand, microservice-based system tends to change their architecture approximately every sprint. That is, every sprint you probably face with a new microservices or a new storage or a new connection between microservices. And thereby to have an up-to-date security documentation for microservices system is a challengeable task because you need somehow to collect that information, update it probably every sprint, and more importantly, use collected information on a daily basis to make your application more secure. Moreover, that process should not take too much time and not disrupt your developers. Next slide proposes what architecture security specific information can be collected in order to implement application security activities. I should mention that proposed approach is a just starting point and applicable when you don't have any established documentation process. So the first step is to identify and describe your application functionality services that are services that implement business-related functions. For example, storing customer details or displaying product catalog. And you should collect the following information related to each microservices. The firstly, unique service name or ID in order to identify those list of services. Very short description of business process or functionality implemented by the microservice. And I think 1 or 2 sentences are enough. Link to source code repository. information on development team which own or develop the microservice, because it is usual to have several development teams are working on the same product. And if microservices expose external interfaces and you have some kind of specification like Open API or Swagger specification, you should also specify a link to the interface description. You may also collect some additional information like a link to microservice runbook or microservice internal architecture description. If you have such information, it is not necessary, but it may help you. You should not collect too much information. For example, information about third-party components or libraries used in microservices can be extracted from source code repository via analyzing POM files for Java-based application, for example. And to collect that information about application functionality services, you can investigate project repository and testing environment, collaborate with system architect or system analyst and lead developers. The second step is to identify and describe building blocks about some functional services. So, for example, infrastructure services like API Gateway or UAA, service about authorization and authentication. And roughly speaking, infrastructure services is a general purpose services, including remote services, that does not implement any business-related functionality, but implements some general functionality like service registration and discovery, UI, API gateway, security token services, authorization, OAuth2, or something like that. So you should collect the following information related to each services, unique service name or its ID, short description of functionality implemented by the service. For example, authentication, authorization, service registration, discovery, link to the source code repository if you have source code, link to the service documentation that includes services API definition, operational guidance, runbook, as something like that. So, and to collect this information, you can investigate project repositories, collaborate with the system architect or system analyst, lead developers, and also you can investigate a testing environment in order to understand what is infrastructure services used by your product. The next step is to identify data storage. So it could be a database system, database management system, it could be a cache. You should collect the following information like unique identifier and software that implement the data storage, for example, PostgreSQL or Redis or Apache Cassandra. And again, to collect that information, you can investigate testing environment, you can investigate some configuration file from project repository, and again, collaborate with your development team. Because event-driven architecture is widely used, widely adopted pattern, there should be a messaging system in your architecture, like Apache Kafka or NATS or RabbitMQ. So the step number 4 is to identify those messaging system and to collect information on their unique ID and the software that implement that message queue, like Apache Kafka or Rabbit. And to collect that information, also, again, you can investigate or test an environment, parse configuration, YAML files, and investigate a project repository. And also, you can interact with a system architect, development lead to understand and to gather information about message queue. And the final step, dealing with the collecting information on the building blocks, is to identify data asset. So that step is more intelligent than other, because you cannot just inspect your repository or execute a command to list all assets. To identify data assets, you should actively collaborate with the other member of your team. Like system analyst or product owner or business architect, and obviously you could not identify all data assets at once. So it is advisable firstly to identify assets which are valuable from a security perspective. For example, user information or payment, and then step by step I identify other assets. And you should collect the following information, like unique asset name or ID, asset protection level if applicable. For example, if you understand that your asset called user data contains some personal information, you should put it on the table. And you can also add some additional information about that asset. After you identify and describe the building blocks of your system, you have to collect information on relations between those building blocks. The typical relations types are service-to-service storage, service-to-service relation, service-to-storage relation, and asset-to-storage relation. During service-to-storage relation, you should identify direct connection between services and storages and collect information on service name, storage name, and required access type for services. For example, in that example, the service called user details has a connection, has an access to storage Postgres called PG1, and the access type is a read-write. Or on the other hand, other services can may only have an access type read. And the main source of that kind of information, again, is a testing environment, again, is some configuration file, and your development team. The next relation you should identify is asset to storage relations. So you should collect an information of the following parameters, like an asset name or asset ID that you identify above, storage name, like a PG1, and also you should specify a storage type for the assets. It could be a golden source or it could be a cache. Next point is that service can synchronously interact with each other via HTTP protocol or gRPC. So you have to identify those interactions and describe it using parameters like the caller service name, called service name, protocol or framework used, and the short description. For example, in that table, the service called user details interact with a service called UA, which is actually service for OAuth 2 authorization, and use for that interaction HTTP protocol. You should also specify some short description and short purpose of that communication. For example, is it a request for query of information? Is it a comment for a state change in business function? And also, you should specify data passed between services. And if possible, you should use data assets ID identified above to describe that interaction. So, for example, if we identify that we have an asset like a user security attribute, and you have a interaction between service user details and service UA, and you understand that during this communication, service user details gets user security attributes from UA service, you should put it on the table. Services also can interact with each other asynchronously, so via messaging queues. So you have to identify those interactions and describe it using publisher name, subscriber name, message queue ID, and a short description. And again, if possible, you should use data asset ID identified above to describe that interaction. So, for example, in that table, the service called user details push their information on updated user home address into Kafka message queue, and that information for a service called MS2. You may store collected information in a simple spreadsheet or Confluence page, and in the future you can even create some kind of digital twin of your microservice system. That is an application that collects architecture-related information automatically from repositories or some storage, store that information and help you to automate your application security activities. It is also advisable to create a graphical presentation of application architecture building blocks and relation defined above in form of service call graph or data flow diagram. In order to do that, you can use a special software tool like Enterprise Architect or even PowerPoint, but it is more advisable to follow a principle of architecture as a code approach and use some language like, for example, dot language to describe your architecture. You can simply define building blocks and relation between those building blocks using dot language statement and visualize if necessary. So to be more useful, you should avoid to represent all data flows, but only data flows with identified assets. You can also use labels like HTTP or gRPC in order to make your diagram more informative. So here is an example. We have some simple architecture. We create some code using dot language that represent that architecture, and that code describe building blocks like front end, API gateway, security token service, and other, and also that code describe a connection between services, and we also can use some labels in order to make our diagram more informative. And you can also create a graphical representation from that code. And this example of using dot language in order to describe your architecture, I think it's a very simple approach, and it is more simple to use some language to describe your architecture than using PowerPoint or Paint in order to draw your diagram. Collected information has to be used during your application security practices. So during defining security requirements or threat modeling or security testing, you should actively use your information on microservice architecture that you gather on in previous steps. So let's consider several use cases based on OWASP SOS requirements. If you're not familiar with OWASP SOS, it is an OWASP project that provides a basis for testing web application, technical security controls, and also provide developers with a list of some requirements for secure development. So you can use it, for example, as a metric to assess the degree of trust that can be placed in your web application. You can use it as a guidance to understand what to build into security controls in order to satisfy application security requirements. And this is an example from OWASP SOS requirements related to authorization. And let's consider several use cases based on OWASP SOS project requirements. So the first example is about threat modeling. So there is a requirement from OWASP SOS that you should use threat modeling practice for every design changes or sprint planning to identify threats and to plan countermeasures. So during sprint planning, you can easily modify your existing architecture diagram or its part to reflect proposed architectural changes, and then have an updated diagram and description of the services and an interaction between services and data asset. You can make some threat modeling activities based on Stride methodology or similar. So let's consider an example where development team proposed to add 2 new connections between front-end application and service called UA, that is a authorization service. And the second connection is connection between microservice called MS1 and service called user details. And also other changes is that in order to implement some features, microservice 1 will start to store some user data that it's obtained from user details services. So we have a user data assets only in a instance Postgres in sprint end. But in sprint n+1, we will have a user data assets also in Redis. So having the diagram and having that proposed changes of your application, you can easily ask some question to your development team in order to make some threat modeling activities. For example, you can ask, do we really need a connection between front-end application and UA application? Can we use the API gateway in order to make that connection, or user details in order to get that connection? The second question is, for example, does microservice one really need an access to user details microservice? And does microservice one really need an access to user data asset? Why do we need that? And asking that question, you can easily create some mitigation for if you identify any threats. You can also make a data leakage analysis. For example, to analyze possible data leakage, you can analyze data flows with the data assets in order to identify possible risks and create some mitigation strategies and define it in non-functional requirements for the next sprint. For example, you can ask a question like, where does sensitive information store it? Are there information leakage via microservice one and Redis? The next example is the next requirements is requirements of enforcing the principle of least privileges. Or again, having an architecture diagram and service description, now you can easily ask question like, does user details microservices really need a read and write access to Postgres? Does microservice 2 really need an access to user details? And when you answer that question, you can identify that identify some issue that can violate the principle of least privileges, and based on the discussion, based on the answer of those questions, you can create some strategies in order to follow the principle of least privileges. You can even use that information during security testing. So, for example, during security testing, during dynamic security testing, you can check that actual configuration file that use microservice called user details with a database account is equal to required permission in the table. So for example, if you identify that according to your requirements, service user detail have to have only read access to Postgres, but during dynamic application security testing, you identify that, or during configuration analysis, you identify that user details microservices use a database account with a read and write permission. You can understand that there is some security misconfiguration that violate the principle of least privileges. And the last example is that you should you should know your sensitive data, and you should make identification on sensitive data. So all sensitive data, according with the OWASP requirements, is identified and classified into some protection levels, like personal information or PCI DSS related information. And again, having a data asset table and asset to storage relation description, you can easily answer a question like, where does sensitive information located? Where are my assets? Does a microservice read or write data asset from specific database or message queue? What microservices are invoked by dedicated microservices, and is sensitive data passed between microservices during its communication? And the answer to that question, you can understand where is your data, where is your sensitive data is located, and create some mitigation strategies to protect the data. Thank you for joining my presentation, and here is some takeaways, some key points. So even if you don't have any established process of documentation of software architecture, you should start to document your architecture, because it will help you to find some sophisticated vulnerabilities like architectural weaknesses, flaw, or something similar. You should document only necessary type of information that may help you in your application security activities, because it will reduce time for collecting and updating information. Do not just collect information, you have to use it at a daily basis during sprint planning or other activities. And you should also keep that information up to date, because main target is not to collect architecture information, but implement mitigation in your application code base based on that information analysis. The next point is that you should use software architecture as a code approach, because it is more convenient and allows you to even use some version control system in order to track changes in your architecture. And the last but not least, do not bury your head in the sand. Collaborate with a developer, system architect, QA, in order to understand application architecture, application functionality, that will help you to more deeply understand threats to your application. And here are some references. The first references is Microservice Security Architecture documentation, OWASP Cheat Sheet, that describe proposed approach on how to collect information related with security for microservice-based architecture system. And the second cheat sheet is a microservice security OWASP cheat sheet. This cheat sheet is about some microservice security architectural pattern that can be used in order to secure your application. And the pattern is from authorization and authentication scope. Again, thanks for watching the video. Thank you. Bye.